Hello and welcome back to Tech Forward, episode 140. I'm Jenny.
And I'm Mark. Jenny, you keeping up with the news from NVIDIA's GTC conference? Specifically, the robotics side of things?
Oh, you know it. The headlines were certainly buzzing. NVIDIA always puts on a show, but it does feel like robotics is taking a particularly big step forward this time. What specifically jumped out at you?
Okay, well, the big headline grabber, I think, has to be Project GROOT. And yes, besides the name making us all think of a certain talking tree, it's actually quite significant.
Chuckles asterisk GROT. Okay, you have my attention. Not a robotic houseplant then?
Laughs. Not quite. It stands for Generalist Robot OO Technology. Kind of a mouthful. But the core of it is GROTN1, which they're calling a foundation model specifically for humanoid robots.
Right, foundation model. We hear that term all the time with large language models like ChatGPT. So how does that translate to a physical robot that moves and interacts with the world?
That's the key question, isn't it? Think of it as, the robot's foundational understanding of the world. It gives these humanoid bots a general ability to perceive using sensors, to reason about what they're seeing and hearing, and then to decide how to act. It learns from a mix of inputs, natural language instructions, watching videos, even direct human demonstrations, and importantly, simulations.
Simulations? You mean like training them in some sort of advanced video game?
Yeah, sort of, but way more sophisticated. We'll circle back to that because it's super important. But the big news about GROTN1 is that NVIDIA is making the core model, called Isaac GROT-NEX open source.
Okay, open source. That definitely lowers the barrier to entry, usually. Why is that such a big deal in the robotics field specifically? Isn't building the hardware hard enough?
Oh, it is. But building the brain is arguably even harder. Or at least just as complex and costly. Creating the sophisticated AI needed for a truly generalist humanoid robot from the ground up? That's a massive undertaking. It takes huge amounts of data, computing power, and specialized expertise. By providing this foundational AI model, NVIDIA essentially gives developers, whether they're startups, university researchers, or even established players, a powerful starting point.
So they don't have to reinvent the wheel every single time? They get this. Let's call it a starter brain, and then they can focus on tailoring it for specific skills or jobs?
Exactly. One team might fine-tune it for warehouse logistics, teaching it how to pick and pack items efficiently. Another might focus on assisting technicians in a manufacturing plant, maybe helping with quality control checks. It accelerates the whole development cycle considerably.
That makes intuitive sense. Faster progress, potentially more diverse applications because more people can participate. You mentioned specific companies getting involved?
Yeah, the research highlighted General Motors, for example. They're apparently seeing significant improvements in production line flexibility during pilot tests using this kind of tech. Imagine reconfiguring a line much faster because the robots can learn new tasks more easily. The research suggested potential development cost reductions around 70% in some scenarios, which is substantial.
70%. Wow, okay. That's a number that gets executives' attention. So GM is using it. Who else is partnering up?
Well, they announced collaborations with some big names in the robotics space. Boston Dynamics is one. Everyone knows them from those viral videos of their incredibly agile robots, like Atlas.
Oh yeah, the back-flipping robot. And the dog-like ones. Their stuff always looks like it's straight out of science fiction.
Right? And it's getting more real. The research mentioned Atlas is using NVIDIA's Jetson Thor System-on-A chip. That's a piece of hardware specifically designed to handle the intense AI computations needed for robots like Atlas, right there on the robot itself, not just in the cloud.
Okay, so the hardware is catching up to the AI software demands. Any other robotics companies?
Agility Robotics is another one. They make Digit, that humanoid robot designed for logistics tasks, like moving totes in warehouses. They're also leveraging NVIDIA's platforms. So you see this convergence. Companies building capable hardware are integrating these powerful AI platforms.
So these aren't just lab curiosities anymore. Companies like GM, Boston Dynamics, Agility, they're aiming for real-world deployment. What kind of jobs are we realistically looking at for these humanoids in the near term?
Manufacturing and logistics are the low-hanging fruit, it seems. Helping on assembly lines, moving materials in warehouses, sorting packages. Tasks that are often repetitive, physically demanding, or where there are labor shortages, as the research pointed out. But when you see Boston Dynamics using Jetson Thor with Atlas, given Atlas's dexterity, it sparks ideas about more dynamic tasks, maybe disaster response in hazardous environments, or assisting on complex construction sites.
Working in places too dangerous for people. That's always been a key promise of robotics. Okay, let's go back to the simulations. You said that was critical. Why not just train them directly in the real world? Isn't that the best way to learn?
Yes. The simulation piece is fascinating. Real-world training is slow, it's expensive, and, frankly, it can be risky. Think about teaching a complex assembly task in a real factory. You need the physical robot, which costs a lot. You need the factory space. Maybe you even need to shut down a line. And every time the robot makes a mistake during learning, it could potentially damage itself, expensive equipment, or even pose a safety risk.
Right, especially if it's learning to interact near human workers.
Precisely. So NVIDIA has this platform called Isaac Sim. It allows developers to build incredibly realistic virtual environments, what they call digital twins. Imagine a perfect replica of a factory floor or a warehouse layout existing entirely inside the computer.
Digital twins. Like a simulation sandbox, but mirroring a specific real place?
Exactly. And they announced a new tool called Cosmos, which helps generate these complex, physics-accurate virtual worlds based on simple text or image prompts. Within these simulations, the robot AI running the GROT model can practice tasks for thousands or even millions of virtual hours. It can learn, make mistakes safely, and refine its skills much, much faster than is physically possible in the real world.
So it can practice, say, picking up a specific type of box, or navigating a cluttered path over and over again in the simulation before the code ever runs on the actual physical robot?
You got it. And the realism of the physics simulation is key here. They mention the Newton physics engine, which interestingly is a collaboration involving Disney Research and Google DeepMind, alongside NVIDIA. Better physics means the robot learns behaviors that transfer better to the real world. Things like how objects feel, their friction, how they react when pushed or grasped.
Wait, Disney? That seems like an odd partner for robot physics.
Chuckles. At first glance, maybe. But think about Disney's expertise in animation and animatronics for their theme parks. They're masters at creating believable physical movement and interaction. Improving physics simulation helps train robots to move and manipulate objects more naturally and effectively.
Okay, that actually makes a weird kind of sense. Better virtual physics leads to better real-world robots. It really feels like all these different elements, the GROOT AI model, the powerful Jetson hardware, the Isaac Sim and Cosmos simulation platforms, are slotting together.
It's very much an ecosystem play. Provide the foundational intelligence, the specialized hardware to run it efficiently on the robot itself, and the sophisticated virtual proving grounds to train it safely and rapidly.
Okay, Mark, you knew this was coming. The big, slightly uncomfortable question. We're talking humanoid robots, powered by increasingly capable AI, destined for factories, warehouses, maybe more. We have to talk about the impact on jobs.
Yeah. It's the unavoidable question, isn't it? And the research we looked at definitely flags job displacement as a major concern. One source, McKinsey Global Institute, projected potentially hundreds of millions of jobs globally could be affected by automation by 2030. That's a sobering thought.
It really is. And while the argument about addressing labor shortages holds some water, particularly in specific sectors or regions, it still points towards a massive transition for the human workforce.
It's a huge transition. There's no simple answer. The counter-argument, also present in the research, is the creation of new jobs. Roles needed to design, build, program, maintain, and manage these robotic systems, and the AI behind them, plus entirely new roles we haven't even conceived of yet.
But the skill sets are vastly different, right? A factory worker on an assembly line doesn't instantly become a robot maintenance technician or an AI trainer.
No, they don't. That's why the conversation inevitably turns to retraining, upskilling, and adaptation. The research mentioned things like demands from labor unions for wage insurance funds, or the need for proactive, adaptive workforce policies from governments and corporations.
It feels like the technology is moving so fast, and the societal and policy responses are struggling to keep pace. It's not just times we build these advanced robots, but how do we integrate them into society in a way that benefits everyone, not just the bottom line?
That's the crux of it. It requires a multifaceted approach. Technological innovation coupled with thoughtful policy, ethical considerations, and investment in human capital. It's a societal challenge, as much as an engineering one.
And beyond the economic impact, there's the safety element we touched on earlier. Humanoid robots working closely with people in dynamic environments. How do we guarantee safety and predictability?
That's where the extensive simulation and rigorous testing become paramount. You have to try and anticipate countless edge cases, unexpected obstacles, human behavior, sensor malfunctions, and ensure the robot fails safely or behaves reliably. Foundation models like GROT are designed for better generalization, meaning they should theoretically handle novel situations better than robots programmed for very narrow tasks.
Theoretically better, but not infallible, I imagine.
Definitely not infallible. There will be a continuous need for refinement, robust safety protocols, clear ethical guidelines, perhaps even independent auditing and certification for robots working in certain environments. It's an ongoing process of building trust and reliability.
So to kind of wrap our heads around this NVIDIA GTC news, it feels less like they unveiled one specific robot that will change everything, and more like they presented a comprehensive toolkit, the AI models, the chips, the simulation software, intended to empower the entire robotics industry to build more capable humanoid robots, faster.
I think that's a perfect summary, Jenny. They're laying the foundation, providing the infrastructure for what could be the next major wave in robotics. And by open sourcing key components like the GROT Next model, they're inviting broader collaboration and, hopefully, accelerating innovation across the board.
It's going to be fascinating to watch how different companies and research groups take these tools and run with them. And, of course, how we as a society navigate the complex economic and ethical questions that come along for the ride.
Absolutely. The next few years are poised to be very dynamic in the robotics field. Seeing how quickly these advanced systems move from simulation into real-world pilots and deployments, like at GM or potentially in completely new areas, will be telling.
Definitely something we'll keep tracking here on Tech Forward. Okay, that's about all the time we have for today. A huge thank you to Mark for guiding us through NVIDIA's latest robotics advancements.
My pleasure. Always fun diving into the future of robots.
And a question for our listeners as we head out. Thinking about your own workplace or industry, where do you see the biggest potential, or perhaps the biggest challenge, in integrating humanoid robots? Let us know your thoughts on our social channels using hashtag #TechForward.
Great question. Looking forward to hearing what people think.
Join us next time on Tech Forward. I'm Jenny.
And I'm Mark. Keep exploring.